When it is dissolved in water, it forms an alkali and it is obtained in alkaline form in the earth crust, hence it is known as alkaline earth metals. As we move down the group, the ionization enthalpy will be decreases. Similarly, when a beryllium reacts with the nitrogen, it forms what? Beryllium nitride. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called S block element. Under that, we have discussed about some important compound, that is sodium chloride, and their preparation and their uses. And also we have discussed about sodium hydroxide and their preparation by Kastner-Kellner processes, and also we have studied about the uses. And finally we have talked about the sodium hydroxide, their preparation as well as their uses. And lastly we have discussed about the biological importance of potassium as well as with the sodium. Today, let us move on to the next topic of this unit about the alkaline earth metal. They are nothing but a group 2 elements and their electronic configuration, physical property and the chemical property, and finally we are going to discuss with the uses of alkaline earth metals. So firstly, I'll go with the introduction part. We all know that group 2 elements are also known as alkaline earth metal. Only the reason is when it is dissolved in water, it forms an alkali and it is obtained in alkaline form in the earth crust, hence it is known as alkaline earth metals. Okay, and the members of these groups are the beryllium, magnesium, calcium, strontium, barium and radium. They are known as alkaline earth metal. Except beryllium, we call this group element from the magnesium to radium as a alkaline earth metal, and they are generally soft and have a silvery appearance. Okay. Next is electronic configuration of alkaline earth metals or group 2 elements. Okay. So the first member is beryllium. Their atomic number is 4 and it has an electronic configuration of helium 2s2. This indicates that in all this alkaline earth metal, there are 2 electrons which is present in their outermost shell. Okay. And the next element is magnesia and it has a 12 electron and there are 2 electrons in the outermost shell and the electronic configuration is neon 3s2. Similarly, the calcium which has 20 electrons and it has an electronic configuration of argon 4s2. Similarly, the strontium denoted as Sr, there are 38 electrons will be there and it is represented as Kr, that is 5s2. Similarly, the barium which is represented as Ba, it has 56 electron and it is represented as xenon 6s2. Similarly, the radium which is represented as Ra, there are 88 electrons will be there and it is represented as radon 7s2. I show you the outermost electrons in all this element by taking the magnesium as an example. We know that there are 12 electrons will be present in this magnesium. We write the structure of atom by taking the magnesium. We know that in the K shell there are 2 electrons will be there and in the L shell there are totally 8 electrons will be there. So it is 10 is over, then remaining 2 electrons. This is K, L and M. So you can see that in the M shell there are only 2 electrons will be present and hence this group of elements they have a valency of 2. Okay, and they generally having a general electronic configuration of noble gas NS2. Always remember when I talk about the alkaline earth metals, always it has a 2 electrons in its outermost shell. Okay, it has 2 electrons in its outermost shell. Next is ionization enthalpy. Due to the fairly large size of atom, alkaline earth metals, they have low ionization energy compared with the p block element. Down the group, ionization energy will be decreases as the atomic size will be increases, which indicates that as we move down the group, the ionization enthalpy will be decreases. Already we have understood that what is ionization enthalpy or ionization energy. It is the energy required to remove the last electron from the isolated gaseous atom. Is it right? So, as we move down the group, we have understood that their atomic number will be increased. So, that is why it is very easier to remove the 2 electron as well as the next electron which has been present with the different shell. That is why this ionization energy will be decreases as we move down the group due to the increase in atomic size. Okay. This is due to the new shell which is being added up, which is increasing in the magnitude of screening effect of the inner shell. As we move down the group, what will happen to the number of shell? It is also get increased because of the increased atomic number. So that is why it is very easy to remove the electrons from the last shell, so that increasing due to the atomic size, this ionization energy which is also get decreased. Okay. So the member of group 2 have a higher ionization energy value as it is compared with the group 1 because of the smaller size, and with the electrons are being attracted towards the nucleus, correspondingly they are less electropositive as it is compared with the alkali metals. When we compare the ionization enthalpy to the group 1 and the group 2 members, they have a higher value because of less electropositive nature, and also they are more stable. So here I have a ionization energy, that is first ionization energy of beryllium is 899, and for the second ionization energy will be 1257. So this indicates that it is very difficult to remove the second electron which is present in the next shell. Is it right? That is why this ionization energy will be decreases as we move down the group, because more energy will be required to remove the electron from the next shell. Okay. Next is hydration enthalpy. Alkaline earth metals have more hydration enthalpy than alkali metal because of the size of alkaline earth metals are smaller than the alkali metal. When we compare the alkali metals with the alkaline earth metal, this alkaline earth metal, they have a very small size, hence their hydration energy which is also high because it can easily dissolve in aqueous medium and produces the energy. Is it right? Or produces the heat. Hence their hydration energy will be very high. The reason is the charge on the alkaline earth metals will be 2+. We represent the sodium as sodium plus and we represent the magnesium as magnesium 2+. Is it right? Why is it like that? Because we know that group 1 elements, they carries the +1 as their valency. Whereas the group 2 element, their valency is 2, which means that consists of 2 electrons in its outermost shell. The 2 electrons are readily available for bonding or to lose. Is it right? Hence, because of the charges which is present in our alkaline earth metals are greater than that of the alkali metals. As a result of this, nuclear attraction will be increases because of the smaller size of the alkaline earth metal combined with that of the alkali metal. Hence, they have a hydration energy greater as it is compared with the sodium metal. So, like alkali metal ions, the hydration enthalpy of alkaline earth metals, which is also in this order, first comes to the beryllium, magnesium, calcium, strontium and barium. So, the same order we have learned in case of first group also. Is it right? Like that, the alkaline earth metals also, they have their own degree of hydration enthalpy. Since the hydration enthalpy of alkaline earth metal ion are larger than those of alkali metal ion, alkaline earth metals are forms extensively hydrated compound as it is compared with the alkali metal. For example, magnesium chloride, calcium chloride. For example, magnesium chloride can form magnesium chloride hexahydrate, calcium chloride hexahydrate, while sodium chloride and potassium chloride do not form this hydrate. It is very, very important. So, what does it indicate here? The statement which indicates that as we compare the alkali metals with the alkaline earth metal, we know that because of the smaller size of this alkaline earth metal, which can easily loses that electrons and forms a more hydrated compound. The best example is magnesium chloride hexahydrate. Such compound will not be formed in case of group 1 element. That is why at the beginning I have stated that alkaline earth metal, they have a more hydration energy as it is compared with the alkali metals. Next is atomic and ionic radii. Atomic and ionic radii of alkaline earth metals are smaller than that of the corresponding members of alkali metals. This is due to the fact that the group 2 elements have a higher effective nuclear charge, allow the electron to attract more towards the nucleus, and this reduces the size of the atoms as well as with the ionic radii. As we move down the group, radii will be increases due to the gradual increase in number of shell and the screening effect. So, as we move down the group, what will happen to the atomic radii? It will be increases. That is the first thing. But when we compare the atomic radii with the alkali metals, alkali metals, they have very less or very low atomic radii as it is compared with the alkaline earth metal, because alkaline earth metals, it has a very high atomic radii as well as with the ionic radii. Here you can see that atomic radii and the ionic radii of the group 2 elements, that is beryllium, magnesium, calcium, strontium as well as the barium and radon. After losing its electron, what will happen? After losing its ion, we can say, okay, their ionic radii will be get decreases. Remember, these values are almost higher when it is compared with the alkali metal. As we move down the group, what will happen to the atomic radii? It will be increases because of the number of shells which is increases as we move down the group. That is why atomic radii or ionic radii which is also get increased. Next is physical property. Due to the presence of 2 electrons in the valence shell, the stronger metallic bonds are formed as a result of this close packing of atoms and due to the presence of stronger alkali metal bond. Alkaline earth metals have higher melting point and higher boiling point and higher density and harder than the corresponding alkali metal. So, as we have already understood that there are 2 electrons which is present in its outermost shell. Because of the 2 electrons are readily available for bonding, it will form a more stronger bond. Hence, their melting point will be high, their boiling point will be high, and the density is also very high as it is compared with the group 1 element, because group 1 elements, it carries the +1 as the valency. So, next is characteristics flame coloration. So, as we have already understood that the group 1 element which consists of only 1 electron in its outermost shell, they are also responsible for forming the colors. Here also, since our alkaline earth metals which consists of 2 electrons, it is also responsible for giving the different colors. All of the steps you will done in your first PUC as well as in your second PUC. Hope you know this test as well. So, except beryllium and magnesium, alkaline earth metal which imparts a characteristics color when it is heated in Bunsen flame. This property is due to the excitation of their valence electron. When the elements of the compound are introduced to the flame, the electron will absorb energy from the flame and get excited to the higher energy level. When these electrons are returned back to the ground state, it emits the radiation in the form of in the visible region so that we can absorb this region in the visible wavelength. Depending upon the wavelength of the light which is get emitted, different colors will be obtained. The best example is calcium, which gives a brick red color with the flame, strontium which gives a crimson red, barium which gives an apple green, and radium which gives a carmine red. This is how when you hold this compound in front of the flame, what will happen? The electrons, the two electrons which is present in the valency shell, they absorb the energy and get excited. When they get excited, it will come back to the original state by emitting the radiation. This emitted radiations will be absorbed in the visible region. So that is why we can see that different colors will be obtained from this compound. Next is chemical property. We'll discuss the important chemical properties of alkaline earth metal. Firstly, I'll go with the reaction towards the air and water. The beryllium and magnesium are almost inert to the air and water because of the formation of oxides and layer on the surface. Okay. The powdered beryllium burns with the air to form a beryllium oxide and beryllium nitrate. So when a beryllium treated with the oxygen, it forms what? Beryllium oxide. Similarly, when a beryllium reacts with the nitrogen, it forms what? Beryllium nitride. The magnesium is more electropositive, burns with the air, and dazzling sparkle will be produced when it is burns with the air. So magnesium combines with the air and forming what? Magnesium oxide. Similarly, when it is react with the nitrogen also, it forms what? Magnesium nitride. Calcium and strontium and barium react differently, readily with the air and forms a respective oxide and nitrides, and the calcium, barium and strontium reacts vigorously even with the cold water and forming hydroxide. This is how when the alkaline earth metal reacts with the air, it forms metal oxide. Next is reaction with the hydrogen. All alkaline earth metal except beryllium combines with the hydrogen directly and forming a metal hydride. So you can see that this is a general reaction where metal combines with the hydrogen and forming a metal hydride. So the hydride of beryllium can also be obtained by the reduction of barium chloride. So when you take the barium chloride, allowed to react with the lithium aluminum hydride, you will get a barium hydride with the formation of lithium chloride and aluminum chloride. This is how alkaline earth metal, when it is react with the hydrogen and forming a metal hydride. Okay. So both beryllium hydride and magnesium hydride are covalent compounds and having polyatomic polymeric structure, whereas the hydrides of other element, it may be strontium, it may be calcium, or it may be radium, all these hydrides are ionic in nature, and all the hydrides of alkaline earth metal, when it is react with the water, it liberates the hydrogen gas and thus it will be act like a reducing agent. You can see that the metal hydride, when it is react with the water, it forms a metal hydroxide with the liberation of what? Hydrogen gas. This indicates that all these elements are reducing in nature. Okay. Next is reaction with the halogen. When alkaline earth metal reacts with the halogen at evaluated temperature, forms a halide with the type of MX2. You can see that the metal, when it is react with the halogen, it forms what? Metal halides will be formed. For that, you can take one more example, that is magnesium reacts with the chlorine and forms magnesium chloride. Okay, this is the best example for forming a metal halide. Similarly, the reactivity towards the acid. The alkaline earth metal can readily react with the acid and liberate the hydrogen. The general reactions will be goes like this. Metal react with the HCl and forming metal halide with the liberation of hydrogen. I can take the calcium for this. Calcium react with the 2 moles of HCl to form what? Calcium chloride with the liberation of hydrogen. Similarly, you can write strontium react with the 2 HCl and forming what? Strontium chloride with the liberation of hydrogen gas. This is how when alkaline earth metal reacts with the acid which liberates the hydrogen. Next is reaction with the ammonia. Like alkaline earth metal can also dissolve in liquid ammonia and gives a blue-black solution which consists of ammoniated ions and that can be recovered later. So here you can see that this is my metal reacting with this moles of ammonia forming what? Metal ammoniated ions as well as ammoniated electron. You can see that both the positive as well as the negatively charged will be developed when it is dissolved in ammonia. Remember, during this complex formation, it gives us to the blue-black color. Next is reducing characteristics of alkaline earth metal. Alkaline earth metals are weaker reducing agent than alkali metal because of ionization enthalpy of alkaline earth metals are higher and their electrode potentials is less negative as it is compared with the alkali metal. So when you see the SRP value, that is standard reduction potential value, it will be lesser and lesser negative as it is compared with the alkali metal, and also their ionization energy will be high. Their reducing characters will be increases down the group. In case of alkali metal, this is because of the tendency to lose the valence electron or increases down the group. So even though beryllium has a less reduction potential than other than alkali earth metal, it is a very good reducing agent due to the high hydration energy and high value of atomization of energy. This is how because of the ionization enthalpy and high hydration energy, and also this alkaline earth metal, they have a standard reduction potential is less negative as it is compared with the alkali metal. They also act as very least reducing agent. Next is uses of alkaline earth metal. The beryllium will be used in a manufacturing of alloys. Okay, the copper beryllium alloys will be mainly used in preparation of high strength springs, and metallic beryllium can also be used to make the windows of X-ray tube. Similarly, the magnesium forms alloys with the aluminium, zinc and manganese and tin. The manganese and aluminium alloy will be being light in mass used in aircraft construction. Manganese used in flash powders and bulbs and incendiary bombs and signals, and the suspension of magnesium hydroxide in water will be used as antacid in medicine, and magnesium carbonate can also be used as one of the ingredients in the toothpaste. Next is calcium. The calcium will be used in extraction of the metal from the oxides, which is difficult to reduce with the carbon, and the calcium with the barium metal, owing with the reactivity with the oxygen and nitrogen, they are at evaluated temperature. They are often being used to remove the air from the vacuum tubes, and radium salts are also used in radiotherapy, especially for the treatment of cancer. So, by this, we have completed the physical and the chemical properties of alkaline earth metal. In the next class, we are going to understand more about the general characteristics of compounds of the alkaline earth metal. By this, I like to say that what are all the things which I covered in this session, it is very important for the examination point of view. Have a look on it. We'll meet you in the next session. Till that, take care, be safe. Thank you.